Welcome to Foundations 30. This is lesson 1, simple probability of a single event. So what we're going to look at in this lesson is just a quick review of probability back from grade 9 and a little bit of Foundations 20, some definitions like sample space and event, and how we calculate simple probabilities. Okay, so just a reminder that a probability of something is the chance that it's going to happen. You can actually give probability in 3 different ways. You can express it as a fraction in lowest terms. You can give it as a decimal, or you can also give it as a percentage. So all 3 of those are acceptable ways to express your answer. I tend to usually work in fractions and lowest terms just because that's the way that my brain works. But if you want to work in decimals or percentages, those are equally as likely. And if it doesn't specify in a question how to give your answer, then it is completely up to you. So just a reminder, to determine the theoretical probability, the probability of an event happening is the number of favorable outcomes in the event divided by the number of outcomes in the sample space, okay? So what the sample space is all of the possible outcomes. So for example, if I was rolling a 6-sided die, all of my possible outcomes are the numbers 1, 2, 3, 4, 5, and 6, okay? And then the number of favorable outcomes is how many of those outcomes in the sample space are what I am asking to find in the question. Okay, so this question says, what's the probability of rolling a number less than 5 on a regular 6-sided die? Okay, so again, the sample space is the numbers 1, 2, 3, 4, 5, 6. The favorable outcomes, which would be our event, is the numbers 1, 2, 3, 4, because those are less than 5. So we write our probability statement. The probability of getting less than 5 is 4 out of 6, because there are 6 possible outcomes and 4 of them are less than 5. So we must give that as a reduced fraction, or as a decimal, or as a percentage. Okay, you can just multiply that decimal by 100. Those are all acceptable answers. Just a reminder that the maximum probability, the highest, so if something is for sure going to happen, that probability would be 1 or 100%. And if it's impossible for it to happen, that probability would be 0. Okay, let's go through a couple of simple examples. This is going to be rolling a die. So keeping in mind that my sample space is 1, 2, 3, 4, 5, 6. Those are the things that can happen when I roll a dice. So what is the probability of getting an even number? Well, out of these 6 possible outcomes, 3 of them are even, so when I reduce that, it's a half, and this wants them as fractions in lowest terms. The probability of getting something that is divisible by 3. So again, out of my 6 possible outcomes, the ones that are divisible by 3 are the numbers 3 and 6, so that is 2 out of 6, which is 1 out of 3. The probability of getting a number whose square is greater than 20. So the square is greater than 20. So that means when I take the number and I square it, what is the value? And is that value larger than 20? So for example, 1 squared is 1. That is not larger than 20. 2 squared is 4. That is not larger than 20. 3 squared is 9. Not larger than 20. 4 squared is equal to 16. Not larger than 20. 5 squared is 25. That is larger than 20. So that would be a favorable outcome. And 6 squared is also larger than 20, so that would be a favorable outcome. So out of these 6 possible outcomes, 2 of them are favorable, so that is 1/3. Okay, the probability of getting a number less than 7, so probability of less than 7. Well, out of the 6 possible numbers you can get, all of them are less than 7, so 6 out of 6 is 1, right, or a 100% chance that's going to happen. And the probability of getting a 10, well, out of the 6 outcomes, none of them are 10, so that's a probability of 0. Okay, let's look at one more example. In the game of Scrabble, each letter is printed on a wooden tile, and then the 9 letters in the word calculate are placed upside down and mixed on the table. Okay, then we're going to pick a letter. What is the probability that we get a vowel? Okay, so there are 9 letters in the word calculate. We know that our vowels are the letters A, E, I, O, and U. So there are 1, 2, 3, 4. 4 of my letters in the word calculate are vowels. and it wants me to make these as decimals to 3 spots. So that comes out to be 0.444. Okay, the probability of not getting a vowel, so just to recall from our set theory unit, if I want to say not an event, I represent that with a line over top, and it's always 1, subtract the probability that it could happen. So the probability of not getting a vowel would look like that. So again, you could just count them up, but I know that in total there's 9 letters and 4 of them are vowels, so the other 5 are not vowels. So that comes 2.556. The probability of getting a C, so out of the 9 letters, 2 of them are C's, so that comes to 0.222. And not a C, well, that's going to be 7/9, which would be 0.778. Okay, running myself out of space here, but the probability of getting a T, so that's just 1 out of 9. And the probability of not getting a T would be then 8 out of 9, which is 0.889. Okay, so you could go ahead and practice just simple probability. There's dice, there's cards, marbles in a jar, sum of a dice, one of the questions. So you'll need to make a chart that represents the sum of rolling 2 dice. All right, go ahead and practice now.